Hey, we're gonna move into chapter 8, and before it lets you know, the textbook only has 2 chapters left that we haven't covered through. Chapter 8, chapter 9, we combine those together. Chapter 8 is supposed to be 3 lessons, 8, 1, 2, and 3. Chapter 9 is 3 lessons, 9, 1, 2, and 3. However, I've added a lesson because I think they assume a lot on the textbook. The textbook assumes a lot when we get to 8, 1 that you might not all know about. So before we really begin, I just created this extra lesson called 8-0 just to kind of blend together what we did in chapter 4 with what they assume you know for lesson 8-1. So, first problem. As we go through today, I want you to first look at the diagram here. How many triangles? Remember, triangles mean straight edges, 3 sides connected. How many triangles do you see in that image right now?
4.
Some people say 2, 3. I've heard 4. Well, let's draw. If I went here, would you say that's a triangle?
Yeah.
Was that one of my triangles you're seeing?
Yeah.
All right, great. Okay, what about a second triangle we're seeing? Maybe here?
Yeah.
Okay, now this is where some people are like, those are the 2 I saw. How are others seeing 3 or 4? Put them together, very good. If you put them together, you get a triangle. Let's get a new color. If you put them together, whoops, I didn't mean to go that far below it. If you put them together, you have a triangle. Very good. Someone else said 4. Is it all straight lines over the 4? No, the 4th, when most people, if you said 4, were you talking about with that curved line right there? I shouldn't say line. Lines don't curve. Should just say curve. That wouldn't make a triangle because it's curved. So we have 3 triangles here. Rule for today, before I actually start solving this problem. You ready? The rule you need to think through today is this. If you see on your diagram there's more than 1 triangle, we're going to have to do 2 insolves to solve it. So I'll say it again. If you see your diagram that has more than 1 triangle, you're going to need to do how many insolves to solve the problem? 2. If you look at the diagram and you see 1 triangle, guess how many insolves we're going to do? 1. That's going to be the general rule for the rest of the year. There's going to be 1 exception to that today, just 1 exception. But other than that, if you see 1 triangle, how many insolves do we have to do? 1. If you see 2 triangles or 2 or more triangles, how many insolves do you have to do? 2. Doesn't matter if it's 3 triangles, 4 triangles, you'll do 2 insolves. That's how we're going to progress the rest of the year. So now let's do this problem here. It says from the top of a 100-foot tall building, that's this side over here, a man observes a car moving away from the building. If the angle of depression of the car changes from 46 degrees to 22 degrees during the period of observation, how far did the car travel? Okay, so one more time. How many triangles are here? 3. So how many insolves do we have to do? 2. So here's how I write this out. If you see more than 2 or more triangles, I want you to think of this as being 2 steps. Here's your first step. Step 1. Is everybody tracking with me? You're going to want to write this down. Trust me, you're going to want to write this down because this will apply the rest of the year. You want to solve for the shared side. Solve for shared side. Now, right now, you're kind of thinking about like, okay, now, solve for shared side. We said there's 3 triangles, so they all share a side. What do I look for? No. Here's what you look for. You're going to either look at what I look at is what I'm trying to solve for. I'm trying to solve for x. X itself, just the length x, only belongs in 1 triangle. Like it only makes the entire side of 1 triangle. For example, is x the entire side of a blue leg in the triangle? No. When you look at the blue, is x even a part of the blue triangle? Yes or no? I hear one vote or no.
No.
No. Okay. Make sure we're all on page. Now, out of the red and the green, x is used in both of them, but it's only used as the entire leg in 1 color. What color is that?
Or is that
The red. You see how the red is in the x is in the red? We have to use the red triangle. The other triangle that we're going to use, we get to pick. So we can choose either one. It won't be any more hard or any less difficult. So what would y'all rather use? Would you rather use the blue in the red, or do you want to use the green in the red? Either way, we have to use the red because of side x is the red triangle. You want to do blue and red? Okay, so here's what we're going to do. We're gonna solve for the shared side, and we're gonna use in the blue triangle. Do we have to use the blue triangle? No, we're choosing the blue triangle. So solving for the shared side in the blue triangle. Come over here to this piece, and I want you to write the word shared right there. So you know what I'm talking about. That's the shared side. Now, why is that the shared side? That's the only place the blue and the red meet. Do you see how that's the only place the blue and red meet? Now, if you would have chosen green and red, we would have had a different red shared side. Is that shared for green and red? No. No, if we were doing green and red, you would have used the top piece. That's the one that's perfectly shared, not the bottom. They're not perfectly shared, but the top is perfectly shared. That would have been the shared side. So you pick the one that's perfectly shared between your shapes. Everybody cool with that? So we need to solve for the shared side. We had rules earlier in the year about law of sines and law of cosines. Those are the only two formulas I'm going to use today. Law of sines, law of cosines. So let's start with the blue triangle. In the blue triangle, I have 100 feet and I have 46 degrees. Would that be a law of sines or a law of cosines? Are they a set or not a set? That's a set. We have a law of sines. Do you remember this? If you have an angle and the side across from it, you have a law of sines. So law of sines, you can go to your formula chart if you want to look at it. It is law of sines. Law of sines, right? Whoops, that's not what I wanted to do. The law of sines is this one right here. It says if we take sine of angle A over side length A, you can set that equal to sine of angle B over side length B, which would be equal to sine of angle C over side length C, which basically means any set is equal to any other set and within one triangle. Okay, so here's our set. So here's how we'll solve this. In the blue triangle, we're going to say that sine of, now here's what you got to make sure you get right today. What goes in the sine, the 46 degrees or the 100? 46 degrees. So sine of 46 degrees over 100 will equal, now we want to find the shared side here. So I need to know the angle across from it. What angle is across from the shared side? Perfect. The 90. It's right here. It doesn't show you a little box, but we assume it is a building. Unless it's the Leaning Tower of Pisa, most buildings are built straight up. So that's across from a 90. That's so ugly in there, but that is a 90 degrees. I'm going to take that away. So I want to do sine of 90 over the shared side. I'm going to do S for shared. We cool with that? Yeah. All right, let's do our first insult. Let's go see what we get. So open up your calculator. Simon's up here. Open up your calculators. I'm going to go do new document, don't save. I'm going to clear out a bunch of stuff each time. Here you go, Valerie. Okay. So I'm going to press menu 3-1, menu 3-1. That gets up my insult. Control divide. We're going to do sine of 46 degrees over 100 equals sine of 90. By the way, shortcut today. I'm going to say these a bunch of times until you get it down. 90-degree values. We're going to have a lot of 90s. If it's sine of 90, that reduces to become a 1. So anytime you have a sine of 90, if you just want to put the number 1, that's fine. Sine of 90. What is sine of 90 going to equal all day? 1. Not just today, but always. If it's cosine 90, it equals 0. So this is a little shortcut. Over S. Now, if I press enter right now, it'll say error. What did I do wrong? Comma S. Press the trig button to get to the sign. All right, today we're around the 2 decimal places. So I'm gonna press enter and then I'm gonna hide mine because I want to make sure you have done it yourself. So we're gonna round to 2 decimal places to the nearest hundredth all day. What are you getting here?
139.016.
139. Point. Okay, now I'm gonna wait for more people. It's gonna be 2 decimals. So I want you to think about if it should be like 0.15, 0.01, 0.99, 0.02, 0.98. Like what should it be? All right. What values? 5, 4, 3, 2, 1.
0.02.
0.02? I agree. 0.02. Okay, that's your first step. So anytime you have more than one triangle, you're gonna have to do 2 insolves. The first is to solve for the shared side. Okay, the second step. We good? The second step, you switch triangles and you solve for the missing side. So now I'm gonna solve for x. Solve for x using the shared side. So now I can go to the other triangle. Which triangle am I now using? We're transitioning out of the blue shared or the blue triangle. What triangle now will we use? The red. We're now going to use this red triangle. We're now going to the red triangle because that's where x is. So this shared side, we just solved for it. What did we just get that shared side was equal to? 139.02. I'm going to stick that in. 139.02 is equal to the shared. So now as you come to this triangle, you ask yourself, do I have a completed set? Can I use the law of sines? What do you think? Can we? Yeah, we can. What do we have as a completed set?
22 degrees.
22 degrees with 139.02. So I'm going to use the law of sines. Everybody tracking with me again? So we're going to do sine of, is it going to be sine of 22 degrees or sine of 139.02?
22 degrees.
22 degrees over 139.02 equals. Now we're trying to find this x.
46. 46 degrees.
So x, we're still missing the angle. We need to find that angle. Okay, let's think about what this angle should be. What's up? Oh, you got this angle right here, 134. I agree, that is 134. If you're wondering what do you do, well, why don't you tell us? What did you do to get 134 there? Yeah, you took the 180. Every straight line has 180 degrees and you subtracted 46. I have a question though. So 134 would go right there. Is that across from x? No. So you can do one of two things. Every triangle has a total of how many degrees? 180. So we could subtract 134 and subtract 22 to get this. Or check this out. It's 22 degrees to this green line. It's 46 degrees to this red-blue line. 22 degrees to the green-red, 46 to the red-blue. How many is in between these two reds? How'd you get 24? You subtracted. This is 24 degrees in there as well. You can find out that way. This is 24 degrees right in here. This has 24 degrees. Let me sneak that back in here somewhere. That's 24 degrees. Again, how is it? Because what's the difference between these two? 46 minus 22 is 20. 46 minus 22 equals 24 degrees. Or you could say there's a total of 180 in the red. That's 134. That's 22. If you subtract them, you'd also get 24. I'll show you that math. 180 minus that 134 that Osvaldo called out, minus the 22. This also gives us 24 degrees. So either way, we now have a complete set. This 24 goes with x. Let's insolve this and we should have our answer. So we don't have a rounding error today. I want to show you a neat little trick on the calculator. After you do your menu 3-1 for insolve, do your control divide, sine of 22 degrees. Now, oh, mine's different. I had this 24 here. It's not gonna work. What I was gonna say is control negative. If you press control negative, it says ANS. What do you think ANS stands for? Answer. And it would copy, for me, this 24. I was planning on it copying this, but I forgot I just did math, so that won't work. So what I am gonna do, though, so I don't have a rounding error, is once you're to this blank, you see how I'm highlighting that blank right now? If I press the up arrow and go highlight the answer, I can just press enter to copy it. No. That didn't work either. Well darn. Well, I guess I just gotta do the old fashioned way. We'll type it in. 139.01. I don't want a rounding error, so I'm gonna type in as many decimals as I see. For you, it'll be less decimals. Mine shows more. I'm just gonna type them in. You can just press control answer if you don't have the previous value. Equals sine of 24 degrees. Don't forget the degree symbol up in the pi. And the pi button, don't forget the degree symbol, you'll be getting different answers. Whoops, I didn't do it right here. Degree symbol over x. If I press enter right now, it'll say error. What's my problem? What did I not do right? Comma x. Okay, I got what the value is supposed to be. What are y'all getting for your answer? Someone other than Miguel. 5, 4, 3, 2, 1. 150.94. Great. We're gonna make sure we got our units right today. What unit was this in to begin with? I have it kind of covered up right there. Feet. So the answer, we're gonna make sure we have the units on the answer. This is 150.94 feet, approximately 151 feet. Is the answer there. Those are your two steps. So what are the two steps? Solve for the shared side between the triangles, and then secondly, solve for x. By the way, if y'all would have said use the big green triangle, we would have got the same answer, but we would have needed to use this as the shared side, the green red. So whatever side is shared between the triangles you need, that's the side you use as shared. We chose blue and red, so this was the shared. If we would have said green and red, it would have been this one. We had to use red though, because that's where x was. So that's the strategy for today. So if you might be thinking, well, we did see one of these in lesson 4-7. You are totally correct. I showed you one of these. What's different today? Today, from here on out, I don't just give you the degrees. Today, I'm preparing you for what the textbook's going to do. What the textbook's going to do is going to give you directions from a compass. So, state of Texas says, this is called a TEAK here, that the students will be able to use trigonometry and mathematical and real world problems, including, here it is, the word you need to know today. Circle this, directional bearing. Now, what is this directional bearing? Well, I'd like you to pause now, pull out your cell phones. Okay, so from your compass app, we learned that 0 degrees always points which direction? North. Well, why does that matter? Because earlier in chapter 4, what was different is we were using this unit circle, and which way did 0 degrees always point on a unit circle?
Right.
To the right. Now that's because we didn't care about north, south, east, and west. We were just showing you mathematical problems. But on a compass, not everything in the real world is mathematical. Real world means real world. So where is 0 going to be set? Is it just going to be set to the right? Well, no, that wouldn't work because my right is not necessarily your right or someone else's right. It all would matter on which way we're pointed. So which way are we going to say 0 is? What does 0 represent?
North.
North. Okay. You need to know these if you don't yet. North points on a paper up. Does that mean north is actually up towards the ceiling?
No.
No. Good. Okay. That's north. What comes next? East. Never eat. What'd y'all learn? Soggy waffles. Never eat soggy waffles. Never eat shredded wheat. Never eat sour watermelon. Never ever smoke weed. Whichever other one you might have learned, you need to know those, that's the order. We good on that part? Okay. This is called a bearing. A bearing, I can't see anymore. A bearing starts which way?
Clockwise.
Due north. What does due north mean, do you think?
North.
This word due means perfectly north. It starts perfectly north, and which way does it rotate?
Clockwise.
Clockwise. So we're going this direction as you go around. That's how we do real world problems. So chapter 4, we dealt with mathematical problems. That just means stuff that's just pure math. In the real world, we use directional bearing because it's not just like all on a piece of paper. So we're going to blend in some chapter 4 into what will become chapter 8. By today, we're just going to use directional bearing to what's kind of the problems like the bell ringer. All right. Everybody ready to get started? Great. Number 1. It says a shoreline runs north-south. I'm going to pause. Here's what I do. North-south means which two directions on a piece of paper?
Up and down.
Up and down. Go to the line that's up and down and put an N at the top and a S at the bottom. A shoreline runs north-south and a boat is due east. Due means, again,
Perfect.
perfectly. That means perfectly east. So here's the boat. Perfectly east would obviously be this dashed line, which means this would be to the west going this way. That makes sense. We cool there? Now, I just filled those in. Did they give us those at the beginning? No, I just filled them in. Again, this is what the textbook assumes you'll do in the future, so I'm just walking you through how to do it. It says the bearings of the boat from 2 points on the shoreline. So I want you to draw 2 dots. They did not give us this. These are the 2 points. Draw 2 points there. Are 110 degrees and 100 degrees. So if it just says 110 and 100, where do you assume it's coming from in a real world problem? What direction do we start at?
North.
North. So draw an arrow from the north that curves to your line like that and put 110 degrees. And the second is 100. Now, how do I know which one's 110 and which one's 100? This one has more of an angle than this one. So I'm going to say this one's 100, this one's 110. It says assume the points are 150 feet apart. How far is the boat from the shore? Okay, so now that we've drawn all that, now that I've just gone through the drawing, let me ask the question you're going to ask yourself for moving forward. Do I see one triangle or do I see multiple triangles?
Multiple.
Multiple. So if we see multiple triangles, how many insolves do we have to do to get our answer?
2.
2. So what I'm going to do is I'm going to colorize. Is that a word? Colorize my triangles so I can call them by color. This will be our blue triangle. And this will be our red triangle. We could use the large triangle again, but are you all okay with just using the 2 smaller triangles? Okay, what was our first step? Last problem.
Use the solve for the shared.
Solve for shared side. Solve for shared side. So in this one, oh, I didn't even put the X on the problem. What are we trying to find? How far is the boat from the shore? What would that be?
South.
This line?
Oh,
Yes or no? No. This line? No. This line?
Yeah.
Okay. So we're going to finish with the red triangle. So that means that we're probably going to start in the blue triangle. So let me write blue triangle up here. We need to solve for the shared side. So the shared side is right here. Would y'all agree with that statement? The shared side is right there. This is the shared side. That's the shared side. Okay. So on this triangle, let's see how we can solve it. I see this is 100 degrees. Do I know how many degrees are on this part of the triangle? How did you get 70? You need to remember that rule of geometry. A straight line has a total of how many degrees? 180. So this angle right there is going to be 70 degrees. Whoops. Let me do it this way. Let me try this one more time. We're going to say 70 degrees there. Now, what's the math? Now I'm going to write the math. We took 180 and we subtracted 110, and that's how we got 70. What about this angle? Could we find this angle? How many degrees would be in there? I heard 10, I think, from Romeo, and he was right. Why is it 10 degrees? Where's 10 degrees coming from? A triangle has a total of 180 degrees. So if you take 180 and you subtract your two angles that are in there, 170. You subtract 100 and you also subtract 70. How many are left over? 10. Okay, so ask yourself, am I going to do the law of sines or law of cosines? Do I have a set? I do have a set. What's my set? 10 and 550. Very good, Osvaldo. We have a set. 10 and 550 are a set. So if you have a set, we use the law of sines. If you remember, this is where you take the sine of the set. What's the angle on the set?
10 degrees.
10 degrees. And you divide that by its side length across from it. Equals any other set in the problem. Well, we want this shared side. What angle is shared? What angle goes with the shared side? 70. Very good. We're working in the blue triangle. So it'll be sine 70 over S for shared. Now, when you go with the calculator, make sure you type in the degree symbol. I forgot to say that early on, last problem. Let's make sure we type in the degree symbol. What am I doing? There we go. Make sure you type in the degree symbol. All right, so I'm going to go new document. I don't want to save. And add a calculator. We're going to do menu 3-1, not control, sorry. Menu 3-1. There we go. Insolve. Fraction, sine 10 degrees. Where's the degree button again? Pi. Valerie, you got a calculator? You need one today. Okay. Did you already type it in? Oh, why am I calling on you? Dominated already. All right, great. Control divide, sine of 70 degrees. Why am I using a letter S again?
That's for the shared value.
That's the shared side. That's what S stands for all day. S is going to be for shared. I'm doing that so we don't mix up and think that's our answer. All right, press enter. What are you getting? Vanessa, what'd you get? Oh my goodness. Bianca, what'd you get?
2,973.
Sounds good. That's what I'm getting. So S is coming in at 2,000. Was it 900? 31? 76.31. That's what it was. And again, because that unit is feet, this would also be feet. Okay, so does that mean we're done? We found the answer? No, that's the boat from this part of the shore, but the boat is closer to this part of the shore. So now let's transition triangles. So now we can solve for x. How can we solve for x, or why did we not do solve for x earlier? Because we needed to know the shared side. Solve for x using the shared side. And this time I want to do a better job of being able to use my calculator. So now we're transitioning into which triangle now? Red. Now only use values from the red triangle. Don't use any values from the blue unless it's the shared side. Which the shared side we got that we just solve with 2976.31. That's what we just got there. Okay, in the red triangle, will we use the law of sines or law of cosines? Very good. What do you see that's a completed set? Perfect. So we're going to say sine of 2976.31 or sine of 90?
90.
Sine of 90, which by the way, today or anytime in the future, if you see sine 90, what will that become? 1. You could just write the number 1 if you want. Over 2976.31. That's going to equal. Ooh, you jumped ahead. Sine of, I don't know, over x. You said 80. Where did you get 80 from? Every straight line has a total of 180 degrees. If 100 of them are right there, that would be 180 minus 100. And 180 minus 100 is 80. I agree. It's going to be sine 80 right there. Okay, type this in solve. We'll have our answer. So this time, the trick, what I was saying, menu 3-1. No, I had the wrong thing. I want to do control fraction. Okay, sine 90. What could you type in instead of sine 90 if you wanted? 1 over. Now this time I'm going to do control negative. That says ANS. What does the ANS mean? Answer. It'll copy your previous answer. It won't round it. So you'll get a perfect answer here. Control divide sine of 80 degrees over x, comma x. What do we get for our answer here?
2,931.
All right. How about David? I'll let you call that once you get there. What you coming up with? Ooh, I got a different number. Check your work. Are y'all getting 2,931.09?
Yeah.
That's what I'm getting. Check your work. Somewhere there, we made a mistake. 2931.09. 2,931.09. And again, we're in feet. So our answer, that would be our feet this time. All right, that would be your answer. All right, let's do this again. Number 2. So number 2 says a U.S. Coast Guard patrol leaves Port Cleveland and averages 35 nautical miles per hour. That's called knots. Traveling 2 hours on a course of 053 degrees and then 3 hours on a course of 143 degrees. What's the boat's bearing and distance from Port Cleveland? Okay, this one's going to be the one rule breaker. Actually, it's not going to be a rule breaker. How many triangles do you see when you look at this picture?
2.
2. If you have 2 triangles, guess what you're going to have to do?
2 answers.
2 end solves. But this one's going to be a little bit of a rule breaker on how we solve it. It says first, we go on a course of 053. Where does that mean we begin from? If it just says 053, where do we begin from? North. Come over here. A is the beginning of this problem. I want you to put begin on your notes. You begin here. That's Port Cleveland. And we're going to end at C. This is the end. So 053, that means you begin from the north and you go 53 degrees this way. You don't have to keep the 0 there. So I'm going to just put 053. Now we travel 35 nautical miles per hour. Here's what that means. You go 35 miles. The math word per means divide. 35 miles per hour. Well, how many hours is that? Is that 0 hours? 1. You're not allowed to divide by 0, so it's a 1. 35 miles per 1 hour. And you do this for 2 hours, it says. So I would multiply times 2 hours. Now, using English, we'd put an S there, but I don't want you to be confused. Those are the same unit of time. So you're dividing by a variable, you're multiplying by a variable. What happens? What's the relationship between dividing and multiplying? They're opposites. So hour and hours cancel out. They're opposites, they cancel. So it's 35 miles times 2. 70 miles. That means we travel 70 miles right here. So go to this part of your triangle, put 70. Now I'm going to pick back up. And then that means now what? The boat turns 3 hours on a course of 143 degrees. Okay, so where do I begin from if it says 143? Where do you always begin from? North. Okay, so point B, I moved the boat. The boat's new north is not this way. North has not gone diagonal on me. North should be straight up still. So from this point, we move forward. There's a new north. So that's my new north there. And now I travel 143 degrees. Which means this. How many degrees are in between 143 and 53? 90. Because they're 90 degrees separating them, this is a right angle. So you see that box there? That means that's 90 degrees. Okay, but we traveled 3 hours. So let's do this math again. We were 35 miles per 1 hour. But now we do this for 3 hours. All right, so hours and hours. Once again, hours and hours should cancel out. And so 35 times 3, we need to know what that amount is. 35 times 3,
105.
it's 105. You can think of it as 70 plus another 35. It's going to be 105 miles. So go ahead and let's write this in on our problem. This is 105 miles here. Okay, on this triangle, what's a little bit different is we're looking for what's the boat's bearing and distance. Now, this will be one where we have to do 2 insolves, but it's going to be for a different reason. It's not because we have to solve for a shared side and then the other side. What's going to be different, and this is the only time it'll work this way, is number one, we have to find out what's its distance here. I'll use the letter D. We need to know what's the distance from A to C. What's that distance? And then we need to know what is this angle here to find the exact bearing. Okay, so let's start with this distance here. Using this triangle on the outside, let me make sure we're looking all at the same triangle because there are 3 of them in there. Looking at this triangle, can we use the law of sines or do we have to use the law of cosines this time? Can you sit up for me, please? Sines or cosines? What do y'all think? Do we have a set or do we not have a set? So inside the triangle, I only know one angle. Do I know the side across from it? No. So I can't use law of sines, so I have to use law of cosines. So let's go over to our formula chart. Let's find that law of cosines. The law of cosines, there's 3 of them. I'm going to highlight this one right here. The reason I'm highlighting this one is because that's a capital B here. Actually, since that's a capital B, I should have called this a lowercase b. Let me change this to a lowercase b just because that's a capital B. That means it's across from it. I'm going to use this first, or the second formula right there. That's the one I'm going to use. Okay. So do we know what B is? Do we know what B is? No, that's our unknown. So unknown b squared, but what are we gonna call a? Make sure everybody's following. What would be across from capital A? That's gonna be lowercase a, and what's gonna be lowercase c? 70, very good. Okay, and we'll plug that in as we go across. Capital B will be this angle here. How many degrees is that?
100.
90. And what did I say cosine of 90 was gonna be? Do you remember? That's right. So the formula says it's b squared, which we don't know, equals a squared, which we're gonna call 105a, and 70 is gonna be c. So it'll be 105 squared plus 70 squared minus 2 times a, which was 105, times c, which was 70, times the cosine of 90. Now, just one more time. What do we say cosine 90 is going to be?
0.
0. So just as we start going along, maybe I should have been doing this the whole time. If that's 0, what happens when you multiply this by 0?
0.
And what about this times this by 0?
0.
Times this by 0?
0.
So basically, you're left with the Pythagorean theorem. Not basically, you are left with the Pythagorean theorem. The answer will be whatever the Pythagorean theorem is. So here we go to solve this. Now I cleared that out. Menu 3(1) will be b squared equals 105 squared plus 70 squared. By the way, you could do comma b here. I'll show you. It'll be the same answer. I'll go ahead and do comma b and press enter. And now I'll do the whole formula and I'll show you it's exactly the same, just to prove the point. Minus 2 times 105 times 70 times the cosine of 90 degrees. Now, what can you tell me about these two answers?
The same.
They're the same because multiplying by 0 just cancels all that out. So our answer should be 126.19 or 0.20. What should we say?
20.
126.19. Very good. So B is approximately 126.19. And what's our unit this time? Miles. We say MI for miles. Very good. There's that answer. Now, that's not the only thing it asks us to find. It also said find the boat's bearing. So we need to find the boat's bearing. So now I need to find this angle. So how could I do that? Well, here's where this is very similar. Once you do one solve, you use that value to solve for the other. So if this is 126.19, if that's what this is, 126.19, how could I solve for this theta? Well, looking inside that red triangle, do we have a completed set now? Yes, we do. We have this set. We now know that sine of 90 is across from B, which is 126.19. And one more time, what can we do anytime we see a sine of 90? We could put the value 1. Sine of 90 is the same thing as 1. Is equal to, now if I need to know this theta, what am I going to use with it? 105, perfect. Sine of 105 over theta. So let's go and solve this and find out what theta is. Oh, I messed up there. Y'all correct me. What'd I do? Oh my goodness. 105 doesn't go in the sign. What does go in the sign? The theta. To make sure you don't have a calculator error, make sure you do theta degrees there. 105 goes in the denominator. All right, so menu 3(1). sine 90. Again, you don't have to type in sine 90 degrees. You could just do a 1. Sine 90 over, I'm going to hit control A and S, or control negative for the answer, equals sine. The theta symbol is also in the pi button. Over 105. Comma. Theta. So now we'll solve for theta. Go ahead, type that in, press enter. What do you come up with? Come on, tonight, what'd you get? You be typing these in for me, please? What are y'all getting? 56.31. Whoops, 56.31 degrees. Now, that right there, I could circle that as theta. That would not actually be the bearing. Where does the bearing start from? Where should the angle begin from if you're doing bearing? North. So is that, this is 56.31 here. Now, is that from north though? It's 53 degrees from north. So from the north, what would that angle be? It would be 56.31 plus 53. What's from the north? The bearing is, what's 56 plus 0.31 plus 53? 109. 109.31 degrees. And just to type that in, that would be 53 plus 50, the answer there. That's where we got that from. All right. Any questions over that? All right, I'm going to take you to your first DOL now. Here you go. You have your first DOL. Here it says 30 knots. That's the same thing as a nautical mile per hour. It's just what I did before. You can do the same math on that. So you're traveling 30 knots. That's saying 30 miles per hour nautically. It's basically the same thing. I'll let you work through and solve this one. Okay, so here's your diagram. Work through, try to solve this problem. You will need to solve for this line here. I'm going to connect it to make it a triangle. How many triangles do you see? One triangle. So if it's one triangle, how many insolves do we have? One. You only have to do one insolve. You go ahead and do that now. DOL number 1. So here are some answer choices for you to look at. Now, let's go on to number 3. Will every problem look like they have so far today? No. Let me show you how they can also give angles. It's a different way. It's called a quadrantal bearing. It's the same thing, but it might look a little bit different. A helicopter is flying from downtown Dallas to downtown Fort Worth. So from Dallas to Fort Worth. The distance between the two cities is 32 miles, as shown here. If the angle of depression, I'm going to pause. The word depression. Let's talk about what that means. Let's say you were going to a psychiatrist. You said, hey, I'm feeling a little depressed. What does that mean? You're feeling down. You're feeling down. Down from where, you might think? This means if you see depression or elevation for the matter, elevation would mean up, from a line that's east-west. So you see how this line's east-west? Go ahead, put an EW, E and W, and the same thing on Fort Worth and Dallas, E and W. So we have two different east-west lines. Just make sure everybody's following. If I didn't put this east on, would that mean that that this direction is east from Fort Worth? Would that make sense? No. For that reason, we don't put that. We just write a second east. From Fort Worth's perspective, this is east. From the helicopter perspective, this is east. Does that make sense? Okay. It says the angle of depression. That means the angle looking down, not the one looking up. The angle looking down to Dallas is west 45 south. Now, wait a minute. This just said W. What does the W stand for?
West.
West 45 degrees south. So looking at Dallas, as you look at Dallas from the helicopter, it's you first look west, then you look down towards, you look down from there. And how much do I look down? 45 degrees. That goes right there. And the angle of depression. Here we go again. What does depression mean? Down from the helicopter. Down to Fort Worth is E35S. What does the E stand for? East. That's where we begin. 35 to the south. So they can give us angles like this. It's the same idea, but we're not starting in the north. Now we're just starting at either east, south, west, north, something like that. Question. How far is the helicopter from downtown Dallas? Meaning, how far is this distance here where the question mark is? Well, let's solve this. First question I have for you. How many triangles do you see? One triangle. What does that mean if you see only one triangle? We'll only have to do one and solve. Before I begin, I need to fill in some values on this triangle. I see this is 32. Do we know what the angle across from 32 is? 32 miles? I heard yes. How do I find out how many degrees goes in right there? How many degrees are there between east and west?
180.
180. It's a straight line. It has to be 180. I'm hearing some students say 100 degrees. I agree with that. It's going to be 100 degrees because what's the math?
180 minus 45 minus 35.
180 minus 45 minus 35. That's your math there. That's 100 degrees. Okay, so will this be a law of sines or law of cosines? Law of sines. We have a set, so we're going to use the law of sines. Because I have a completed set, we will use the law of sines. So that formula says that sine of A, what's angle A going to be?
100.
100 degrees over 32 will equal.
We go X over.
Now we need this question mark. So what goes with the question mark? That angle. Do we know what that angle is yet?
No.
No, we got to figure out what that angle is. It'll be sine of some angle over the question mark. So how do I find out what that is? There's a rule in geometry. It says this. Osvaldo, stay with me because you were the expert in geometry. When you have two parallel lines, these two lines are parallel. How I know? What are they? But what direction are they both going? Say east-west. They're both going east-west, so they're parallel. If you have two parallel lines and a line that connects the two, which we call a transversal in geometry, every alternating interior angle is congruent. Do y'all remember that rule? So if this is 35 here, if I alternate over here, guess what it is?
35.
35. Just the same, if this is 35, if I come over here, this is still east-west. This is a second transversal. If this is 45, guess what this one would be? That would also be 45 degrees. Okay, so for this one, it'll be sine of 35 degrees over the question mark. Let's end solve that. Let's go to our calculator and end solve. New document. I don't want to save this. Calculator, menu, 3-1. Sine of 100 degrees. Where's the degree button? Pi. Over 32 miles equals the ratio of sine 35 degrees over question mark. If you want to use a question mark, there is a question mark just to the right of G. You can use question mark and end solve for that, actually. If I press enter right now, it'll say error. How do I make it work?
Comma question.
Comma, question mark. That should be our answer there. So what should we round that to?
0.18, 6.64.
So approximately, that's what it says. Approximately 18.64 miles. That's the distance from the helicopter to Dallas. Approximately 18.64 miles. All right. One more thing I could have asked you. West represents how many degrees? Here, I'm gonna point this out real quick. West is how many degrees from earlier today? Like on a compass.
270.
270. I want you to think of it this way. If you have a chart northeast, southwest, north, east, south, and west, this is really going for next class. If you're moving from the west to the south, am I moving clockwise or against the clock? Against. Here's how the math on this. You would say 270 minus 45. Why minus 45? Because I'm going towards the south. Does that make sense? So they could have given this as 270 minus 45, which would be the same thing as 225 degrees. This line right here could be represented by 225. If you went back to your compass, let me go back to the compass. I'll show you. This that goes down and to the left from Dallas. Where's my compass? Here it is. What is down and to the left? What do you see? You see how that's 225? That's the math on how to get that. Let me do this one just for added practice. What about here? East represents how many degrees? 90. East is 90 degrees, and then I'm going to have the 35. Now, if I go from east to the south, I'm moving this way. Is that clockwise or counterclockwise? So I would add the two angles. I would add, and so what's 90 plus 35? 125. They could have given the angle like that, or again, they could have given this angle. This one was subtract. They could have given the angle that way. Okay, they could have given them in either form. Just want to point that out. All right, your DOL number 2. You're going to be solving the same thing we've done today so far. Nothing new. The only difference here on DOL number 2 is I'm giving you quadrantal bearing. So here's your problem. The bearing of the line of sight to the east side of the Royal George footbridge from a point 325 feet due north of the west end of the footbridge across the Royal George is north 27 degrees east. What is the length L of the bridge? You need to find this. I've given you everything else. When you see this dotted line going up, the reason they gave you that is because that represents how many, what does this represent? North. That's telling you you start here. This is your north. Which way does east and west go?
Right.
Yeah, east is which one? To the right. West would be, so this line right here is that north 27 east. I'll let you solve from there. Okay. By the way, how many degrees would go right here in this spot? 90. Because if this is north, east, west, then something going north, south would be, you could call this north, south as well, would be 90 degrees. Okay, go ahead and solve that DOL number 2.